Right, so 2013, the CAM question, so it's part B of the question. The first part was the linkage, but part B here is CAM, and unusually it has an involute in it, which is kind of not very common in these kind of dynamic mechanism questions, but look, it is part of the topic. So we'll tackle it. So look, they're giving us the measurement and all that for the actual CAM, and they've instructed us that the curve going from A to B is an involute of the circle, the radius 18 circle that's in the inside. And then they want us to draw the displacement diagram that actually that kind of corresponds with this particular CAM. Okay, so we have to draw the CAM first. So I'm going to start by drawing that radius 18 arc in the center there. So that's that there. So it's radius 18, and I'm not going to draw like the radius 36 arc and all those bits yet, simply because I just want to kind of keep it nice and clean while I do the involute part, because obviously the involute part is the tricky part with this. Right, there's point A at the top, and point B is over here somewhere, but we just don't know where yet. But we'll get there. Now what I do know is that you can see, like, there's a line in the question there that travels from the bottom of the circle across to here, that where to finish B. Alright, so I will have to bring a line out over here. Okay, so B is in line with the bottom of the circle, so when we draw our involute, we'll know where to stop point B. Now, essentially what an involute is it's the unraveling of a particular point. Alright, so if I just roll a tape here, that's the end of where the tape is there for me. So when I start to peel it, you can see it there, right? But if I take this and I start to unravel it and I keep it pulled taut, it's basically plotting the path of the end of the piece of tape. It's not the actual tape itself, but the actual point right at the end. It's the unraveling of that, and basically plotting that point as it comes out from the circle. Alright, and involutes can come from, they can be circular shapes, or they can be done with a square or a triangle or whatever it is. Okay, and they've all got involutes. But in the case of this question, it's just the circle here, right? So I'm just going to divide the left-hand side of my circle into 6, and I am only working with the left-hand side here now at the moment, because I'm not going to need to use the right-hand side because it's not actually that big. So I've divided that side up. Now I'm going to zoom in here a small bit as well, because there's no point in me being zoomed out that far when it's in here or working with. Alright. So now my involute is starting here, so that's my first point. Okay. Now my second point, I've divided this into 6. Alright. Now the 60-degree lines and the 30-degree lines, you can use, it's all done with the 60-degree set square. So where this hits here, what I need to do is draw a line perpendicular to it, like so. Alright, so that's created a 90-degree angle in there. And then what I'm going to do is use my 60-degree here, and I'm going to go perpendicular to that one. And then on my horizontal one here, I can just go vertical. And then I'm going to go 90 degrees here. Then I'll use my 30-degree here. Alright, and this actually here will finish my involute for me. Right, so basically I've gone 90 degrees to each one of those lines at their points on the circle, right, at each one of those. Now what you want to do is you want to take one of these sections here. Okay, they're all equal, so it doesn't matter which one you take, right? So you're basically taking a 1/12 of the circle. Right, and on the first one here, I'm going to mark my first point. Right, so there's the first point of my involute. And on the second one then I'm going to come to this one and I'm going to mark 2. So 1, 2. There's the second point of my involute. On the third one I'm going to mark 3. So 1, 2, 3. There's the third point of my involute. So 1, 2, 3, 4. Okay, you get the idea with this now. There's the fifth point. Oh, sorry, there's the fourth one, should I say. So 1, 2, 3, 4, 5. And then finally the sixth one. Now what I'm going to do is I'm just going to take, that's 5. I'm going to add 1 onto it. Alright, so you can do that. You don't have to mark them one at a time every time. Okay, so that is the involute. Okay, so like it's a fairly simple thing to do. Alright, and it's drawn freehand. Okay, the involute of like squares and triangles, anything that has straight lines, they're actually done with the compass. So you swing them with the compass, and the involute is drawn with the compass. But when it comes to circular things and circular sections of involute, you draw them freehand like this. Okay, so there's that part. Now, as for the rest of it here now, so we have a radius 15 arc here, so I'm just going to pop 15 on my compass. Okay, so that's point B here, that found. So I'm just going to swing my 15 in there, and I'm just going to draw an arc. Right now, I'm not going to darken it in yet, I'm just going to draw it lightly for the moment, because I have a straight line that goes down here as well, that I want to get to, right? No, the arc at the bottom, okay, so this is 36, so the diameter, this is 36, I'm using this as the center, and this swings right around to here. Right now, part of that obviously is going to be dark. Now, the straight section here, right, is just a tangent between the two circles, so the two circular arcs. Okay, now you're not expected to draw the correct construction for a tangent, so just a straight line that actually just touches both arcs tangentially will suffice. So it's just there, and you can come along then afterwards, and I can actually darken in my cam. Then I know how much of this radius 15 arc now to heavy in as well. Just tidy that up. Alright, there's also a radius 8 circle in the middle. Alright, it's actually the camshaft there, so I'm just going to pop that in. Right, now my compass isn't great, so it's a bit awkward to do this. I'll do it anyway. Alright, so that's the camshaft in there. I'll put some hatching through it there, just, you don't have to do it, but just to distinguish it from the rest. Now, okay, so that's the part 1 done. To draw the given cam profile, and plot the displacement diagram. So we have to do that for one full revolution of the cam. Now, the displacement diagram, right, this is always straight above the camshaft center there. That point there is always the nearest approach of the follower, and being the nearest approach of the follower means that it is the bottom of the displacement diagram. Right, and it's a knife edge follower as well, which means we'll actually be using these points. Okay, so that's the bottom of my diagram here now, and I'm going to zoom out because I need to actually use the rest of this sheet here now. I'll try and keep as much of it in there as I can. And I need to pick a point to start Okay, so I'm just going to start my diagram there, right? Now they have asked us to use 15mm gaps for the displacement diagram, so I'm just going 15, 30, 45, 60, 75, 90. Okay, I think that's 12. But anyway, they go 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, 180, 210, 240, 270, 300, 330, and then finally back around to 0, or you can call it 360 if you like. It makes no difference, right? So basically they're going to represent each 30-degree section of this cam. Alright. And I'm going to have to draw a line up each one. Right. Now we don't know yet how tall the displacement diagram is going to be, but we'll figure that out as we go to draw it here now in a second. So, start anyway, right? The center of my cam is the center of my camshaft there, alright? So, I always refer to that as C for center. And I'm going to use a green pen here now just to distinguish it, okay? I'm going to split my cam into 12 parts. Alright, so it's just like how you divide up a circle. They're all just going through the center of the cam, okay? And it is important that they go through the center of the cam and not through point A, alright? Because technically the cam is rotating around the center of this, okay? Now, the vertical one here is 0. Okay, now I just need to check to see which direction it's rotating. So the cam rotates anti-clockwise. Now, there's a rule here with cams that if the cam rotates anti-clockwise, so this way, you label it clockwise. Okay, so with the cams question, if it says label it, or sorry, if it says it rotates anti-clockwise, then you label it clockwise, and vice versa. If it says it rotates clockwise, then you label it anti-clockwise. So this is rotating anti-clockwise, so my first 30-degree section is going to be going in the clockwise direction. This one here will be for 60, this one here will be for 90. Okay, I'll zoom out there in a second, so we can get all those in. Or I can actually probably just move it down. Yeah, there we go. Now, so essentially now, what we're focusing on is every point where my 12 divisions hit my my cam. So this point here, that point, you can see where all those lines are actually hitting my cam profile. I need to transfer those onto my displacement diagram. That's 0 there. Now, we may need extra sections in here for the involute. You know, it just kind of depends on how vague the diagram ends up being. But we'll start with the ones we have. Okay, so I'm going to start with the right hand side here. So basically, this compass goes in the center of the cam here, and I'm going to rotate the 30-degree line, or the 30-degree point, up onto 0. So you can see that, right? I'll color it in blue here. So I've basically rotated that arc around onto 0. and then I transfer it across, and this is for 30, so I'm bringing it over until it hits the 30 line. Okay, and that's a point on my displacement diagram. Obviously 0 here is the start, so it's going to go 0 up to 30, and then I'll do 60. So we rotate that one onto the 0, and then transfer it across, and then I'll rotate 90, transfer that across. Okay, you can kind of get the idea of what I'm doing here. So this one is 120, I'll do 150 and 160 as well, or 180 should I say. So this one's going to 120, this one to 150, and this one to 180. Okay, you can see that there it's a freehand curve, just like so. Right, that's half the diagram. Right, so we are around as far as 180 here. Now, next, what I'm going to do is I'm going to transfer points, the point for 210. So, swinging around point 210, right, it actually ends up being, for me anyway, it ends up being on this exact same one as the one for 150, but it might be slightly different for you, so just work with what you have. Right, so there's my point for 210. I do the same then for 240 and all the rest of them. Okay, so it doesn't really change. So 240 is coming around to there. Okay, 270, 300, 330. Alright, just make sure you're putting them onto the right line. Okay, now in here, okay, like I don't know if this should be a straight line or should they be curved or what the crack is here. So it's a bit vague. Okay, so in this kind of a case, I'm going to add a couple of extra points into my displacement, right? So we've got 30-degree sections here, but I'm going to add a 15-degree section in between each one as well, just for the sake of getting a couple of extra points on my displacement. I think it'll just help it be a bit more accurate. Okay, now I'll pop these in pink. Now, this may not be necessary in the marking scheme, but I think it's just kind of best to do it anyway. So this is 225 degrees, this is 255 degrees, you get the idea. It's 285, this is 315, and this is 345 degrees. And basically where we find those is on our displacement diagram here. We'll just half these again. So I'll put a pink mark. Okay, and just mark halfway between each one. Right, so this is our 2251, this is our 255, this is our 285, this is our 315, and this is our 345. So we do the same thing as we did before, just rotate them. So there now, for example, is the one for 345. There. Okay, and you don't forget to rotate them onto 0. So it's the point where the line meets the cam, rotate it onto 0 and bring it over. So this one is for 315. Okay, so 255 actually ends up being the highest point. No, there probably is a point slightly higher than that, but it's more or less it's accurate enough. Okay, brilliant. Just going to connect that. So that's attempt like a UV type thing. And then I'm going to go freehanding up here. Those points do actually make a straight line, so well, they do for me anyway. So there, again we've another UV type thing. And finally, just a bit down there at the end. Okay, so it's quite an unusual looking displacement diagram, but that is it there. Now the last part was to indicate how tall the displacement diagram is. So that is the highest point, here is the lowest point, and it's a case of measuring that. So for me, and there would be a tolerance with this, okay, so like, you know, not everyone would have the exact same answers. So for me it's 44 millimeters. Okay, so as long as you're within that, kind of within a millimeter or two of that, you should be safe enough there. Alright, so that's how to do that question there anyway.